So when you are going to move to the new college?
Fall. I
No.
think the fall, yeah. I want to
Oh.
do the fall. Yep.
Mm-hmm.
Yeah, we'll see what happens.
Okay.
I was looking at a biotechnology manufacturing program at
Mm-hmm.
URI. I'm not sure. Maybe some others. I'll consider some other things too. I'm taking taking a full load of classes this semester here. Um, I'm taking actually like an intro to business course. Like I'm taking some classes that don't matter. That won't really be transferring, but I could use maybe some of the things that I learned from it. So I'm just taking like an intro to business, and there's another course, intro to biotechnology skills, and
Okay.
that's just it's just extra credits so I can get paid a little bit extra because I'm in a program right now where the VA will pay me to go to school full time, and they'll pay me a little bit extra to take some additional courses, and although I was weighing organic chemistry to take it at the community college, I thought it would still be better to take it at the university and take it with them. But still, to do the tutor sessions with you and basically learn it before I even take it in the course.
Okay. Yeah,
You
you
know,
already. Yeah.
so that was my is basically my approach to it right now. Um,
Mm-hmm.
you know, what are your thoughts, if any?
Nice. That's good.
So just pretty much taking it piece by piece, I guess. If it's available to take in the summer, who knows? Maybe
Summer
I'll.
because you are doing right now, so it's okay. If you are not doing right now, then I will never recommend you to do the summer
Hmm.
because you are already doing the organic chemistry one part. So I don't think it's going to be a problem for you because you are not going to take any other course. Just take only one in the summer,
Yeah,
and you
yeah,
can do that.
yeah. I could take that one by myself, by itself.
Hmm.
That one. I could if I wanted to. Yeah, I could just do it.
Yeah.
So we'll see. Yeah, my little dog is joining me on. She's on my she's on my lap. So,
Okay.
uh, but yeah, I'm gonna just get a few things set up. So uh,
Okay.
I
Today,
loaded those PDF files to my iPad.
okay. The one thing I was thinking again about uh, putting this thing on the YouTube because some things I use like it, which are copyrighted from the book. I don't know whether it's good or not. For example, for like going to the YouTube.
Oh well, you can use like another person's like material, but it's like your, your.
Because when I make my own
I
like
believe.
for teaching purpose, I take it from the book. Whatever the students are using the book, I take from there.
I mean, it's
If
all
I'm te-
it's all essentially borrowed knowledge, right?
yeah,
No one really owns it,
yeah, I don't
really.
put like everything. I don't put like the whole thing. Reading, I just put the main item there for
Right.
teaching.
Yep.
Okay, now look there is
Yeah.
one way. Because today I'm doing the conformation of alkanes. First of all, let me explain what is the conformer or conformation means. First, before we do this thing, let's do like isomers. Isomers have the same formula. They have the same formula, but they are not the. They have like a different structural formula. different structural formula. Structure formula. For example, I am taking example of so let's take CH3, CH2, 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 CH3. What is the IUPAC name of this one? A simple one. I can also write this one like this. 1.
So
Yeah,
there's
it's the
5.
same.
Let's see. So it'd be pentane.
Pentane. So this is called pentane. IUPAC name. Now what is the formula of this one?
That one
Because
there
the general
is
form
is it
C5H12.
H12.
Now I am keeping the same formula but making a different structure. CH3, CH, I am putting branch CH3, CH3, then putting CH2, CH2. If you take a look, still it has 5 carbons and 12 hydrogen. Same thing, alright?
Yes.
This is then also same thing. I am also writing another one. I can write like this one, like 1, 2, 3, 4, and there is one branch I am putting here. Now I am writing the another one for your same formula. CH3, C, and now we have CH3, CH3, and CH3. In this case, what happens? I can represent this like here 1, 2, 3, and now we have 2 branches like this. All of them have 5 carbon and 12 hydrogen.
Oh, they're all.
But their IUPAC name are different. What about the second IUPAC name, which I made here? This one.
This one here is let's see. So it'd be yeah, 2
2-methyl.
2-methyl. 1, 2, 3, 4. So yeah,
Butane.
yeah, butane.
Okay, without any gap. Okay, this is the IUPAC name. But the common name we can also write like this one, isobutane. But I can write, I'm sorry, isopentane. Because iso is this group. This group is iso. So I can write iso for this. The other one, which is pentane, I can write N-pentane. N means like in normal. This is not a IUPAC name, which I am writing in the parentheses right now. The second one, IUPAC, what is the IUPAC name of this one? The third one.
This one right here. Okay, this one here is let's see. Can I check my notes?
Yes.
Or if it's ISO and then ISO, is it can it be 2 of them or no?
No, ISO means ISO is like a, it's not a, in this case it's not ISO, because ISO must have this group.
And then
like this one.
dimethyl.
I don't see like it's a 2,2-dimethyl propane, am I right?
Say again?
2,2-dimethyl propane. Because the long chain is 3 carbon, am I right? Dimethyl propane. Writing here is sometimes make difficult. Okay. Methyl propane. But what is the common name in this case? It is, we can call it like, because there is 2 branches like, am I right?
2 branches.
ISO, normal ISO, and then we call it new pentane. what we call it? Neo. N-E-O. Hold on just 1 minute. N-E-O. This is not IUPAC name. New pentane. New pentane is like this one. So these are not the same compound. They are different compound, but all of them have the same formula. We call them skeletal isomers because the skeleton is different, main chain is different. So we sometimes call this thing skeletal isomers. Also there are other names for this. In this case we also call sometimes chain isomers because the difference is in the chain, main chain, 5 carbons, 4 carbon, 3 carbon, like this one. So these are isomers having the same formula, but they are not the different compound. But in the isomers, one is like a skeletal isomers, the other one is called like a, you can also call it geometrical isomers. You can also call this one as geometrical isomers. So the isomers have two things. You can go like a geometrical isomers, and also you can go another one which we are going to deal later, optical isomers. No, sorry, not optical, stereoisomers. Stereoisomers or isomerism. Isomers, isomerism. Isomers. So in this case, stereoisomers, or you can combine them together. Geometrical isomer, stereoisomers. Actually, you have to combine them together. Conformers are, you can see like the stereoisomers. They don't have different IUPAC name. They have the same skeletal, same thing, but in the space the arrangement are different. The different arrangement in space. They differ in arrangement of atoms in space. And you can say conformation or conformers are class 1 family of stereoisomers. Alkanes, first of all, let's say about the alkane. Carbon makes how many bonds?
4 or 2, depending on the state, right? Oh no,
Carbon
four,
always
four,
makes
four
Four
bonds,
bonds.
right?
Okay. And the structure of carbon, because it is a sp3 hybridized, sp3 hybridization. So what will be shape? Shape is going to be tetrahedral. Tetrahedral shape. And the tetrahedral shape is like a 3-dimensional. It's a 3D structure. 3D structure. Of course, on the paper we make like something like this. Carbon we write like here, then we write here, then here, and then we put like something. This dashed line is like on the back side of the computer. I'm not so good in drawing the picture of this one, so I'm going to go back and show you. Look here in this case. This is carbon making 4 bonds. 2 of them are line. One of them, this is called wedge, and this is dash. Wedge is, this hydrogen is facing towards you, coming out from your monitor towards you. And the dash one is going behind the monitor, away from you, on the back side. This is on the front side. And the line one are on the plane of the monitor, a plane of the page.
Mm-hmm.
So it is like a 3-dimensionally, we can imagine this thing like this. If you have like some ball, and you can also purchase this one.
Mm-hmm.
This is small, like a black carbon and white hydrogen, and also some other.
I forgot to tell you, I have a molecular model set, an organic.
Oh, that's good, because I also had that one.
I have one, and I'm gonna start taken it out. It's brand
Yeah,
new. I
you
haven't
can,
even.
yeah,
I
you
want
can
to. I
check
want to
those.
start looking and seeing what that is.
So this is tetrahedral structure. We are representing on the paper like this. Wedge is facing towards you. This H is going behind you. So this is behind you is dash. And the angle between them is 109.5. Now this is they are representing the ethane. 2 carbon. This is with the front carbon they are attaching 3 hydrogen. With the back carbon they are again attaching 3. And they are representing like this on the paper. This carbon, wedge means facing towards you, coming out from the monitor towards you, and this is going behind the monitor. Same thing is here. 2 sp3 hybrid carbons, this one. Rotation about the CC sigma bond. Because in the single bonds, all the bonds are sigma. So carbon-carbon bond is sigma. So they can easily rotate. Rotation about the CC sigma bond, they can rotate sigma bond. But if it is a double bond, they can't rotate. If there is a double bond, it is just like locking the thing. They can't rotate. Conformations are different arrangement of atoms caused by rotation about a single bond. So when this carbon-carbon bond rotate, the hydrogens also moves with the carbon, and then what happens? We get a different conformations. So let's see about here in this case. So I'm not going like this one. I'm directly coming in this because we can better see this thing in the Newman projection. And how we draw the Newman projection? Let's see this one.
Okay.
You are seeing from here. So when you are looking from this side, this is your front carbon, am I right?
Yes.
And this one is the back carbon, another carbon, behind this carbon, black carbon.
Okay.
So when you are making this is the perspective drawing, which is like normally viewed from the end. And now how we can convert this into Newman projection. The first one, this black line, can you see the black line here?
Mm-hmm.
This where the hydrogen line is meeting here, this one meeting, that's your front carbon, this carbon, black carbon. And the red carbon you don't see here. It is behind this carbon. So you are making a like a ring,
Gotcha.
circle,
Yeah.
and the back carbon you don't see here, it is on the back side. Now this carbon, the front carbon, has 3 hydrogen, am I right?
Yes.
The 3 hydrogen, one on the dash and one on the wedge, you put on the left and right hand side. Left and right hand side. I will explain this where you have to put. And the line carbon, which is on the plane, this one and this one, you put either at the top or at the bottom, up and down.
Oh. Okay.
If you look like this one, I will show you. It is basically, I call it in Y inverted, straightforward Y and inverted Y. It doesn't matter, I can, in my front thing is inverted, or back one is inverted. It doesn't. So I'm just making as the book is making. This one, this I'm making like a circle, and another one I'm making invert like a Y, another one. So there is 2 Y you can see. One Y is like this, one Y is inverted. Can you see this thing?
Mm-hmm. Mm-hmm.
Yeah.
Yes.
It doesn't matter whether in the front I keep inverted, or if front is inverted, the back side is going to be a straightforward Y in opposite to each other.
Yep.
Okay. Before I
So
will
this-
explain this
This
thing
is
further.
this is inverted, and then the Y in the back is regular.
Before we
Is that
go
right?
this further, I'm going to go here.
Mm-hmm.
One thing here. This is the same Newman projection. Okay, look here in this case. This is your front carbon. This one.
Mm-hmm.
It has what? One, you have hydrogen. One, what you have?
It has a
Bromine.
bromine. Okay.
Bromine. Now the bromine is, and now I'm going here. This one.
Mm-hmm.
This one I'm going to explain later, but just for the time being, I'm just going directly here. The one which is on the right hand side of the Y, am I right?
Yes.
Right hand side. It is on the wedge. Can you see it on the wedge?
Oh, okay. Yes, it's on the wedge.
Okay.
Yep.
On the back side, carbon, on the back side of the carbon.
Oh yeah, that.
CH3 is on the left, and look, CH3 is on the wedge.
Mm-hmm.
Can you see this thing? Both hydrogen on the front carbon and on the back side carbon, they are on the left. They are on the dash. Can you see this dash and this dash? So
Yeah.
whenever you are converting from this to this or this to this, be careful. Right side we are going to make on wedge. Left side we are to keep it on dash, back side. And the top and bottom, like CH3 and ET, they are going to be on the line, on the plane. Is it clear?
Okay, got it.
Because it is going to be important for when we are going to proceed further. So that's why I'm going directly here. Now going back where we are doing those things. So this is how we make this thing, new and projection. So they will give you the question like two things. They can give you the formula to make this, or they can give you this one and ask you to write the IUPAC name. Both of them going reverse. Now before this we go further. Because I told you the single bond can rotate, just like your steering wheel can rotate. Right?
Mm-hmm. Mm-hmm.
Now assume this thing, the circle you can assume your steering wheel. This one is, let me, because HHS looks same, so I am putting the number on the H so that I can identify. I am putting 1 H, this one, 2 and 3. Okay. Now you can rotate. So maybe possible that 2 will take the place of 1. Am I right?
Right, right.
If you are moving like this, the steering wheel, the 2 will come here, 1 will come here. Am I right?
Yes,
And
yes.
3 will go there. You can rotate, and you can rotate both of them, front one as well as the back side one. Okay, now during the
Got it.
rotation, let me explain this thing. Now, this picture. When you are rotating, suppose you are not rotating the back side, only you are rotating the front side, only front side you are rotating. So a time will come, then what happens? In this case, they are far away from each other. Can you see? They are far away from this hydrogen, and this hydrogen is approximately 60-degree angle.
Yes,
60
yes, yes.
But now when you are rotating, they both comes on the, they are showing, of course, because anyway we have to show it, otherwise the angle between them is 0. They are actually coming on each other. Okay, so they are 0 degree. This, when all of them are on the same side, that's called eclipsed. Suppose there is 2 steering wheel, both of them are on the same, overlapping each other, then eclipsed. Angle is 0.
Got it.
And definitely this is going to be less stable. Why? Because there is steric hindrance, crowding. So less stable. Now this is when the angle is 60, just like inverted Y, called staggered. So they go from eclipsed to staggered, then eclipsed, then staggered, like this. When the angle is 0, it is eclipsed. When the angle is 60, it is what? Staggered. When the angle become again like moving to the, you are rotating to the 0 degree in the beginning, now rotating to the 60 degree, it becomes staggered. When you further move 60 degree and it's 60 plus 60, 120,
Okay.
again it becomes eclipsed.
Okay.
And again it becomes staggered.
180 is staggered, and then
Like going from 180 and 60 is staggered.
okay.
But 0 and 120 is, you will get eclipsed. Now look here, 0 degree, you see the potential energy is high here.
Yes.
It means it is less
It's at
stable.
its
Higher energy conformers are less stable. As 60, the energy is less. This is stable, staggered is stable. And these angles are called dihedral angles. Again at 120, energy is going up. Again at 180, it's going down. So these two are staggered, are stable. The torsional energy of ethane is lowest in the staggered conformation. The eclipse conformation is about 3 kilocalories per mole higher in energy. At room temperature, this barrier is easily overcome, and the molecules rotate constantly. because
Okay.
this is not
Yeah.
such big difference.
Yep. Yep.
Now this is ethane. Now we are going to the propane, because after this I will give you something to make that one.
Mm.
Propane conformation. Again we are looking from here. C dash H like here.
Mm-hmm.
C wedge dash, and this is on the line CH3.
Got it. Yep.
When you are making, they are saying propane is shown here as a perspective drawing and as a Newman projection looking down the C1 and C2. You are looking down. This is your C1 and this is C2.
Got it.
We are looking C1 and C2. So this is your C1 first. Back side you have C2, and the third carbon is attached with the back side carbon. Now look the front carbon. How many hydrogens are here?
We have 3
3.
on the front
So
carbon. Yep.
this, okay, of course all the hydrogens are same, so it doesn't matter to us, but just for the asking like this one. Where is dash, this dash hydrogen I have to put?
That one is right here.
That's good. What about the wedge one?
That's right there.
And what about the line one? Very good. The same thing is here. The dash hydrogen is your this one.
The dashed one is this one.
Yeah, this one.
The wedge is this one.
This one.
And then we
the
have the
CH3 is,
CH3. We got CH3.
yeah, and the line.
Boom.
What? This is your projection. How you make those things. Again in the propane.
Thank you. Thank you.
Conformation 0, 60, 120, going like this. Eclipsed, staggered, eclipsed. Okay, like this. Now one more thing, because in this case the energy difference is 0.3, higher for propane than for ethane, because it is CH3 group. Now let's see the butane. In this case butane, they are taking like second. Okay, let me, I will go back here. First write this thing here, then we can come later here. Go back. Hold on. What is butane? CH3.
Butane, we have C4H10.
Yeah, I'm writing like this: CH3, CH2, CH2, CH3. Now I am making the, this is first carbon, second, 3, 4. I am taking second and third carbon, making the Newman projection. The front carbon is, the front one I am taking this one, the front carbon, and this one the back side, backward,
Okay.
rear carbon.
Yep.
Okay, and now making the projection. Now first of all I am making the Y. It doesn't matter inverted or I am making according to the book, so that not making any confusion. This one, and I am now making a circle. Okay, now the back side I am making like the straight Y, like this, 2Y. One Y is this, another Y is this. Is clear? Now which one is the second carbon now, Mike?
Just a second. The
Let me
second,
put that
the
different
second
line.
carbon.
Color using that. Okay, let me, I will use the this one, the red one here. Hold. Which one? The red one. Front one is what? Blue one?
The front one is this blue one.
Okay. The front one, carbon, has how many hydrogen?
Two.
Okay, because in this case, let me, I will, because I had not shown dash or wedge, let me, I will show this. I am making CH3.
The way that this
I
looks.
can take a dash. I am putting like this C. One is on dash, one H on wedge, and then CH2 again, one on the dash and one on wedge hydrogen, and then CH3. I'm not showing the CH3 structure. So let's go front one. Front one has two hydrogen, am I right?
Yes.
One on the left and one on the
Right.
right. So I'm putting here one on the left, one on the right. Both of them are hydrogen, so it doesn't matter for me. What about the red one?
Oh wow.
What about the line, first of all?
Wow, so that must be the CH3. Okay.
Yes, 3 on the plane. So I'm writing CH3. Now go to the back side, rear carbon, third number carbon.
Okay. So now we have this hydrogen will be here. And then we have this hydrogen here is going to be on this one.
And now the other one is CH3. No,
And
yes,
then this
CH3.
one here will be right here.
Okay. This is staggered or eclipsed?
That looks like staggered.
Staggered. Now, staggered also has like in the staggered, and especially in like a butane situation. Because in the ethane doesn't matter because all of them are HHH hydrogen. But in butane there is a problem because there are two methyl groups are there. So when they are rotating, even in the staggered form, if you are rotating the front one suppose, and you are moving and CH3 comes here, just behind the CH3. Because CH3 is a big group as compared to hydrogen, am I right? Because carbon and 3 hydrogen is bigger than hydrogen. So two big groups, when they come close to each other in 0-degree angle, like that, there is going to be more strain on the molecule, become less stable, am I right?
Right.
And
right.
when they are opposite to each other, it means they are far away, the big groups are far away from each other. They are going to be more stable. So that two are called anti and gauche conformer in the staggered form. So let me go back here and show you like this. Look, this one is totally eclipsed. This is what?
Oh, totally eclipsed.
Totally eclipsed because all of them are on the 0-degree angle. In this case, it is staggered, am I right? Angle is 60. But the big groups are close to each other. Can you see?
Okay.
So now this is staggered, but we call them gauche. Gauche is like it two methyl groups are close to each other. In this case, again they are becoming eclipsed because 0-degree angle is there at 120. Now again at 180 they are again become staggered. But now the staggered is called anti. Why anti? Because they are opposite to each other, making a 180-degree angle like this one. This one anti is more stable than gauche conformer. Is it clear?
Got it. Understood.
Butane has two different staggered conformation, gauche 60-degree between the methyl groups and anti 180-degree between the methyl group. The eclipse conformation where the dihedral angle between the methyl group is 0 is referred as totally eclipsed. Now in this case they are both eclipsed. Can you see?
Yes.
But this is called totally eclipsed because the bigger groups are very close to at 0-degree.
Understood. Yep.
So which one is going to be more stable? Can you, out of 4, can you start from the lowest stability to highest stability?
Okay.
This
I
one is
think this is lowest. This is the,
very good.
Is the least
What come
stable.
next? Okay, what come next? Higher stability than this. This is I'm giving 1. This is
one.
you are saying 2. That's good.
And then this one is a bit more stable, but this one is the most stable.
No, sorry, not 2. I think in this case because this is staggered are of course they are stable than eclipse because this is also staggered and staggered. Okay, well, we can say of course in this case because hydrogen is there. So that's how we do the thing. Now conformation, let's see here and we can see maybe that's right. This is 0-degree. What is this one? totally eclipsed, right?
Mm.
Higher energy. When it is coming 60, gosh, 60 degree methyl, it is now lowest energy. Can you see?
Yes.
Now when it is going to 120, it is again going to, of course, more stable than this, but less stable than this one.
Mm-hmm.
Staggered are always more stable. So this is gauche, but not the completely, sorry, this is the eclipse, but not completely eclipse. Then again going 180, going energy less, because now the thing is the anti-group is, which is most stable.
Mm.
Then they are going again 240 and they are showing all those things going like this. So look here, going like this, how the energy changes as they move. So definitely the gauche are going to be, sorry, the staggered are going to be more stable. Is it clear?
Staggered are going to be more stable.
Mm-hmm. Now I will give you something and you make this. You try to make this one. I am writing the formula. I am writing the first Newman projection. You will give the IUPAC name of that one. And in order to give the IUPAC name, you have to convert them either in the line formula, bond line formula, or maybe like this condensed formula like this, CH3, CH2 like that. So I am giving you this one. Why not I will use this? Okay, and I am giving you like this one here. Sometimes instead of writing C2H5, they can also write like ET. ET, ethyl is the same C2H5.
Okay.
And PR, when they write PR, it means propyl, C3H7. When they write IPR, it means isopropyl. Isopropyl group. An isopropyl group is like this: CH3, C, CH3, CH, and like this. This group is isopropyl. So I am writing C2H5 here. I am writing isopropyl. I am writing H and H. Can you give how you are going to give the IUPAC name of this one? So let's start with this.
Okay.
Which
So
one
you
is your
said-
front carbon?
You said IPR is isopropyl.
Isopropyl, which is this one.
Okay, all right. So the first carbon, carbon 1, is going to have, let's see. So we want to, well, it's C2H5, so that's going to be...
Okay, one important thing. Right now we are assuming this as a carbon 1, am I right? I will make another thing a little bit different. CH3. Okay, let's take this.
It's ethyl.
Okay.
It's ethyl.
Methyl, this one.
Ethyl is up at the top.
At the
C2H5
top.
is ethyl.
Okay, now what I'm going to do, your front carbon is what? This one, am I right? First write the front carbon and the back carbon. These two. Okay. Whenever you are doing like IUPAC name or writing the condensed formula or bond line formula, just write the two carbon, one which is in your front, one is on the back side carbon, rear carbon. So that's I'm making this one.
Yep.
Now let's start with the front carbon, which is I'm starting. Of course I can start from anywhere, but I'm going from left to right, just like we use the English. Doesn't matter, but I'm just doing like this. This one is C, then C. Front and back carbon. Now the front carbon is attached with what?
ethyl and hydrogen and a bromine.
Okay, I'm writing because I'm not interested in stereochemistry right now. So just I am putting ethyl group. I am putting CH3 group, am I right? And what else? And bromine, am I right? Bromine. What about the back carbon?
The back carbon has isopropyl. It has two hydrogens. Sorry.
Isopropyl group here we have. It has two hydrogen. You're right. Two hydrogen. So let me write hydrogen 2 here. Okay, now I'm opening this one. After writing like this, or maybe I have to put the hydrogen so it becomes easily. We have two hydrogen, am I right?
Yes.
Two hydrogen. Okay. Now I'm writing this again. I'm doing like converting this. C. I am putting CH3 as it is. I am putting Br, which is also okay. I'm opening the C2H5. C2H5 means, this group means CH3, CH2, CH3. So I'm making like here CH2 and at the end we are putting CH3. This is ethyl. On the rear carbon, this one I'm putting H and H. And now I'm putting isopropyl. How is the isopropyl? CH, CH3, CH3. This is isopropyl. Okay. So I put everything. Is it clear?
Yes, I'm just looking it over. Just a second, please.
So I'm converting step by step. First writing whatever is written there. If they write ET, IPR, I'm just writing those things.
Alright, sounds good. Isopropyl. Yes,
Yes,
that's
isopropyl is like,
where this is. Yep.
isopropyl is also like a Y. You can say. It's just like a Y. Why? If you look, take a look. Why I'm saying Y. This is here and Y. Your Y is attached like this. I'm going to write the Y here in this case. Like this. Can you see?
Yes, yes.
Like Y like this in this
Yep,
case.
yep.
So this is the whole thing. Now you already know how to write the IUPAC name. Make a main chain, start numbering by yourself and give the name. Can you do this thing?
I can definitely try. I can try my best, you know?
Yeah.
From
try.
from what we've done. Let's see. Alright, let's see. So I'm just gonna see 1, 2. Yeah, can I go 1, 2, 3, 4, 5? Or would it be
How many carbons in the main chain? Longest
yeah,
chain.
1, 2, 3, 4, 5, 6.
Okay, main chain is good. But from where you have to start the numbering?
Yeah, we're gonna have to start from the right side.
Okay, so give the number. Put the number on the top of each carbon.
Can we do
Yes.
that?
Yeah, that's you're right.
Or we can do here from one, and then this would be a branch, if we wanted to.
Yeah, anything
But-
which is outside the
Okay.
anything which is outside the main chain is branch, except hydrogen.
Okay.
Hydrogen is not a branch.
Okay.
Hydrogen
so
is a part of this.
so this
chain.
this means here. Let's see. So we have methyl. So that's No, I'm sorry.
Okay, what are
We
the
have
groups there?
we have a methyl.
I'm going to put, for a explanation purpose, I'm making a group outside the main chain. This is, hold on. This is outside, which I'm circling is. This is my outside, and this is outside. Am I right?
Mm-hmm.
These are the substituent, or you can say branch, or you can say exit, whatever you want. Okay. So what is now? 2,4 then dash dimethyl. You have to put the dash after 4. Let's see. Okay. But what about bromine?
I'm not sure. I'm not too sure.
Okay. Bromine starts with B. Methyl starts with N. You have to follow the alphabetical order. Which one you have to write first?
For bromine?
For bromo, not bromine, bromo. Let me write this thing here.
Oh wow.
Hold on, let me see this one. Yeah, no, it's yes, 4. 1, 2, 3, 4. Okay, you're right. 4 bromo, alphabetical order, dash 2 dash 4 dimethyl, and because the main chain is 6 carbon, so hexane. That is going to be our name. Clear? So they will give you this type of, depending on your teacher, they can give you this one and you can write this, or you can give you, yes.
Can that change, like bromo? Could that be something else? Like, how do I know it's bromo or not something else, or is this
Okay, because
or that's the shortened bromine?
Because in the organic chemistry, whenever some groups are there, for example halogens group, halogens are fluorine, chlorine, bromine and iodine. You always end up with the O.
Oh, fluoro, chloro, bromo.
Yeah.
Oh, I got you. This helps. Yeah. This is exactly what I was talking about. Very good. Thank you.
The other groups are, for example, you have used NO2.
Now I am understanding.
NO2 group. We have used this in the inorganic chemistry as a nitride group. Am I right?
Yes.
But now in the organic chemistry, when NO2 is there is no negative charge or positive. It's just neutral attached with something. So I'm going to call it again as a nitro, ending at O. Nitro.
Wow,
okay?
Yeah.
Nitro.
No, thank you very much.
CN, cyano group, normally we say cyanide. For example, if inorganic compound, I am going to say sodium cyanide. Sodium cyanide. But in this case, for the organic chemistry, again you are going to, because we are not telling negative or positive charge, just attach something. So you are going to say this one as cyano. Cyano group is also sometimes called nitrile in the organic chemistry. We will do this. Cyano or maybe nitrile. Okay. Most of the time they are ending at O. Okay.
Very good.
Otherwise there are other things like OH group. So they have like a functional groups. We will discuss functional groups later. Okay. Is it clear, this one?
Yes. Thank you.
Okay. Now I am giving you some question here, and I am giving you now the structure and asking you to put the name. And now I am not giving the name, the structure, even CH3, CH2. I am just giving line, bond line structure. I will give you something like a wedge and dash.
Yeah, I've seen these before, but I didn't know what to make of them. But now I'm understanding it because of you explaining it.
Mm. Okay, now I want you, okay, this carbon is 1, 2, 3, 4, and 5, am I right?
Yes.
1, 2, 3, 4, 5. I want you to make the Newman projection formula and start between C2 and C3. Starting the front is C2 and the back one is. So I'm going to make this thing for you, this diagram like a skeletal, not the whole thing. And you just put the proper group on proper place.
So C2 and C3. So this is my front carbon and this is the back carbon. Is that what you're saying?
Yeah. And also look, the back one, you don't bring the line to the center because it is on the back, am I right? You see the back one, I am not extending it to the center.
Mm-hmm.
It is just staying at the boundary of the circle.
Mm-hmm. Mm-hmm.
Okay, now put the groups. I am not telling you, you have to do it.
Okay, let's see. 1, 2, 3. Okay, so CH3.
What is the front carbon number?
Okay, so this is gonna be a CH3, I think.
You are right.
Right?
Very good.
Okay, now this hair on the right there is going to be CL.
Excellent, because you put on the left and right properly. That's what I want to see.
Okay. Now, if this back ring is the third
carbon.
Let's see. Okay. So we're saying that.
Oh, wait a minute. I made a mistake. A little bit. I want to give you this. This one I have to put here at third. Sorry. I'll put this here. Hold on. This I am putting H, and the wedge I am putting here is ET group.
Okay, just a moment. Okay, so 1, 2, 3. So that makes, so it's 1, 2. So it'd be CH2. Yeah. Okay. This is my thought. And the CH2 right is this. So I.
No, but you have to, then you're writing, you write them, combine them, all of them.
Oh, okay, and this is C. Oh, okay. So that's what I have to do. That's what I have to do. I have to do this too. So that would be 2 carbons. So it'd be,
yeah, you can combine them with C2H5. You can
H5. Write. So it'd be
C2H5.
Ethyl, ET.
Ethyl group. Otherwise, you can write just ET.
Okay, ET.
Okay. So you can write ET or you can write C2H5. That's better instead of writing like this. Okay. You can put C2H5. You can put ET. Is it clear? So it's very easy, not difficult.
Now I know what to do if it looks like this, if it has this and this, that I have to include
If suppose the thing is isopropyl, you don't have to even make
this
it.
and this.
Just put IPR. IPR means isopropyl.
Like if this were to form an isopropyl, just put
Yeah, then
IPR and it
IPR.
would be
That's
fine.
it.
Wow. Okay.
Yeah, you can also write the whole thing, but you can also make it simple like this, and then put, in order to more make it more clear, then you can write like the key. IPR means what? Isopropyl.
Isopropyl. Okay.
Like this. Otherwise, you can write like this. Okay. So now I'm giving you another one more. I'm giving you like this one. So you have to make a line instead of this.
Wow, this one's looking cool.
Okay, now make the Newman projection. And make the Newman projection between 3 and 2 and 3. No, sorry. First we have to, I will give you the number. Okay, I'm not giving the number, but assume it is like between this and this. You take these two. Because I don't want to make it more clear. Maybe it is not 2, maybe it is something else. But just assume. For the time being, you can consider this one.
Yeah, couldn't it go like a different way? 1, 2, 3, 4, 5, like this way too, but no. Okay, let's see.
Because you have to make between, I told you, but you have to make
the branches, yeah.
Like this, around this.
Okay.
They will give you like, because right now I'm asking you to make the Newman projection around this. You can make also other places, but right now I'm on this, around this.
Okay, I'll do this. Let me see.
Let me, I will put the things.
I got it. Let's see. Do we want to put it at the bottom, or hold on?
It doesn't matter. I'm just putting like here.
Okay.
And put this whole thing. You just fit everything here. You use the Mac or PC you are using?
Say again?
For this class, you are using the Mac computer or PC like Windows?
Like for right now, I'm using PC. I'm just using my my mouse.
Oh, yeah, using mouse. Okay.
Yeah, I'm sorry. It's terrible.
No, it's no problem. Because
I have a brand new iPad Pro right in my lap, and I'm trying to figure out a way that I can if we can connect through while I use this.
I don't know because I never used that one. So I like the big screen. That's why I use this like desktop. Like my desktop is out of order because I made, actually it's not a name branded desktop. For the learning purpose, I purchased all the ingredients and made my
Oh
own
yeah.
dust.
Oh yeah.
But,
Absolutely.
but it is more than 10-year old,
Mhm.
so
Mhm.
it was not working
Hey,
properly. So
well, it got you this far, so it worked 10 years, right?
yes,
Let's see.
it's
So
still
this
working,
is
but I don't want to now repair it.
just a second. Let's see. Um, no, I'm just thinking. I'm just thinking real quick. I'm just thinking. So we have the back one is going to be this H, and I know this right side will be. Let's see. We have
Yeah, so far looks good to me.
CH3, CH3, and a C. So that's C3, H6. I don't know. Is that propyl? Is this isopropyl down here?
Yeah, just write IPR, I dash PR,
Yeah.
isopropyl, small letter.
Yeah,
Okay,
there we
yes.
go.
Mm, very good. You did. And now one thing is missing only.
Yeah, I'm trying to
Like
think
about
right now. So I got this. We got this. I'm just trying to think here. So this is a CH2. I'm just going to kind of do step by step. CH2, and then we have a CH2, and then there's a CH3. Alright. So that means we have 5, 6, and 7. C3, H7, and
hold
that's
on,
gonna
just
be
one,
propyl. Wait, that's
just one
propyl.
minute, because this carbon you already have included, am I right? This one. So how many carbons I see outside now? After,
Oh wait. So this one here is the ring itself,
hmm.
right? So that's 1 and 2. Okay. So that's just a second. CH2 and CH3.
What you call that group? And what we write C2H5. You can write
We have
C2H5.
ethyl. Ethyl.
Yeah, you
ET.
can write
ET.
C2H5.
ET.
Yeah, ET is okay. You can write ET or you can write C2H5. It's clear now? So it's not difficult. Once you understand this thing, it's just understanding. It doesn't matter. Okay.
Yeah.
As you converted this like here, you can also convert this back to this one to get the name. Now forget about right now looking the other one.
Mhm. Mhm.
Okay, that I will fix this one and then you try. I'm making a try this again by yourself and now writing like CH3, CH2 like
Or
that.
here I'll yeah, there we go.
Okay,
Yep.
so now I'm writing this. Hold on, just 1 minute. I'm writing here.
I can redo this.
It is so. Just hide that one. The no. Just oh, you are doing this one again. Okay. So now we are not looking the other one. Okay.
Mhm.
Now write this thing as a CH3, CH2 like that, not bond line, and then give the IUPAC name without licking the top one.
Like this.
Hmm. Just write. I'm not writing the
Oh, okay,
characters
okay, okay.
like CH3,
Okay, I got you. I
CH2,
got
and
you.
so on like
Yeah,
that.
okay. So front and back.
Hmm.
I drew it kind of big. I'm sorry, but let's see. So the front one, so
I'll always
it
put
could
at the
go.
center because maybe you don't know how many you have to extend. So put the center here like here so that you can extend on both sides. Which one is your front?
That one. So and this is the back. So
Okay.
the front has this one here, has a H. So I'll do
Don't worry about it, dash and wedge, because I just need the IUPAC name.
Oh, you just want me to name it? Okay.
Yeah.
That's all you want
But
me
if
to
you
do?
want, yeah.
Okay. Let's
But if you
see.
want, you can do that thing for practice if you want.
Yeah?
In the exam, yeah, in the exam, if you want to keep practicing these things, it's okay. But right now, I'm doing only for.
Well, yeah, I don't know, because then this is going to be... This, what is it? CH2, and then it could be...
And then CH. Yes, you're right. Ethyl is this. No, no, CH2, CI. Yes, you're right.
And
So
then
you
you have
already
this...
completed that front carbon. Now,
Mm-hmm.
what about the next backside carbon? Isopropyl means Y. CH and then yes.
Yeah, yeah. CH3, yeah?
Mm.
Oh. And then we have ET. Would that be accurate?
Which one?
Would this be?
Yes, everything is good.
Okay.
Now give the IUPAC name.
Okay.
First, select the longest chain for the IUPAC.
Alright, I'm going to change the colors I'm using real quick. I'm going to change it to blue. So, what did you ask me real quick? I'm sorry.
IUPAC name.
Okay. Just a sec. So I'm going to do 1, 2, 3. Can I go like this? Or never mind.
No, for IUPAC you have to start the numbering from the one end to another end, not from the middle.
Can I do that?
Hmm? Okay. Is there any other possibility you can get more carbon in the branch? What about if I go from here? 1, 2, 3, 4, 5, 6.
Wow.
1, 2,
Okay.
3, 4, 5, 6.
Okay. Yep.
Erase the number and then give the number again.
Can I do this?
Okay, now look here in this case. In this, no, just keep it right now, keep it. I want to show you. Right now, suppose this is 6. If I go here again, I will get this 6. Right?
Mm-hmm.
3, 4, 5, 6. Right now, how many exits? Forget about hydrogens.
Oh, no, you're right.
Don't count the hydrogen as an
You're
exit.
right, you're right.
Hydrogens are not exits.
Yeah, you're right. Yeah, this is not good because I only have one exit.
Only one exit. You're
And-
right.
and
No,
who-
two exit.
And who knows? Which
One
way.
and one, two exit. Because hydrogens are not the exits. You can say it's a rest area. Okay. So these are only, so this one, if you go like here, you are getting one exit here, one exit here, one exit here, three exits. So take that route which gives you more exit, more
So if I go like
substitute, more.
this,
Yeah, that's good. Because now you are getting, look, this is your main chain, am I right? I am circling that main chain, your main chain. So this is your main chain. I am putting everything like here like this. Anything outside this except hydrogen. Because hydrogen you can write also here. No, don't put the hydrogen as a branch. Generally I put the
oh,
hydrogen like here. I put them here instead of writing like there. So don't write hydrogen as, just put with the C. Okay. So now look how many branches you see.
oh yeah,
I'm
yeah.
putting the hydrogen as the carbon. So you will not make a mistake of counting hydrogen
Yep,
branch.
3.
Three branch.
Yep.
So what are those branches?
Yeah, and they're all hydrocarbons. They're all simple organic compounds.
Mm.
Yep. We have
So what is the UPC
methane.
name of?
Oh, okay. So it'd be okay. So it'd be 4 dash ethyl dash.
Oh, wait a minute, wait a minute,
3.
wait a minute, wait a minute. Something wrong. Numbering. In the numbering, we did something wrong. I didn't notice that at that time, but I want you to predict the mistake. I know something wrong, but you have to predict by yourself what's wrong. Was something wrong? You can figure out by yourself. You got it?
Say again.
Something is wrong.
I'm trying to figure it out. I'm looking at it.
It's only wrong in the numbering.
1, 2,
Because when
3.
you are, it's just in a simple way, instead of chemistry, when you are going on a turnpike a route, you take that route which have more exit, and also you have to take that route where you can get the exit as soon as possible. The nearest exit from
Okay.
your journey. Right now your first exit comes where?
3.
Okay, if you go in the opposite direction, starting from the opposite side, your first exit will be at what number?
Oh wow. Yeah. At 2.
2. So start from there. You not only need more exit, you also need the first exit to be a nearest exit. One, two, three, 5, 6.
Okay. So this will be. We have.
Use the lowercase letter, because maybe they will take the point because they know don't use yes. 3 dash ethyl. Very good.
I'm just trying to see. Let's see. We have a 6 chain, so it's going to be hexane.
Hexane, yes, that's it.
Methylhexane.
Is it clear?
Yep.
That's how we do these things. It's not difficult, okay? Now let me, I will go something like one more thing here. This one, we did this thing.
Thank you
And
for showing me how to look at everything differently. Like
this,
thank you.
as you have enough time, you are doing right, starting right now. You are able to do it even in the summer. No problem. Now look here in this case. This is,
Wow.
you already done, know this thing, right? How we convert this into this one. This structure is called sawhorse structure.
Sawhorse. Okay.
Yeah. You know, in the park we have like some
Yeah.
kids say
Oh
that
yeah.
that is
Yeah, it looks like a horse. I can see it
yeah,
now. It
sawhorse
does
like
look
this.
like a horse.
How they convert this? The in this case the front Y is inverted Y. Am I right? Our
Yes.
front Y is inverted Y. So I'm putting
Yes,
the
you're
as
correct.
it is
Yes.
inverted Y. Okay.
Yes. Okay.
As it is CH3 at the top, hydrogen at the left, bromine as the right.
Got you.
Now making a like a tilted upward line
Mhm.
and putting another Y, inverted Y, like in our case the straight Y, and again putting the backside H on the left, CH3 on the right, and at the bottom ET. Am I right?
Got you. Yes, I can.
Exactly, we are doing converting, rotating the projection.
I see.
Once you and now you are flattening like this tilted line is, you make it horizontal like this,
Okay.
and this H which is on the left will become on the dash. You already know that. Right side will become on the wedge. Am I right?
Yes. Yes. I was just looking at that.
Wedge.
That when I saw that.
Once you will practice this, it will be easy. Even I have some difficulty when drawing because I'm not good in drawing. Okay, so you have to memorize, practice this thing. The rest is just put the group.
You did a great job. It looked textbook from what I.
No, it's not. I didn't
It
do
looked
it.
very.
Actually,
It's looking real good.
from wherever I keep looking on all the things. Wherever I get like a best thing, I keep it, save it.
Excellent.
That's my collection is from everywhere, from different universities, from different places. Okay.
Looks good.
And-
Looks good.
And now look here in this case, this is flattened. Dash is left hand side hydrogen on dash, right hand side bromine on wedge. This one CH3 on the line. Can you see?
Yes. Yes. Makes sense. Yep. Yep.
Okay. The back side is H is on the dash because on the left hand side.
Yep.
Another H is also no. Another is CH3 is on the wedge on the right hand side, and the ET group was on the line. Can you see?
Yes. Yes.
Okay, once you did this one, now I'm going to tell you one. After doing this, there is called sometimes they also when you are giving the name of the compound. I just told you give like 2-methyl, 3-methyl, something like that. Am I right?
Right.
But because I'm not going directly to the everything, going step by step. But sometimes before we go there to do that topic, I will tell you about asymmetric carbon. Asymmetric carbon. Asymmetric carbon makes how many bonds? 4 bonds. Now if all the groups are different, all the groups attached to the carbon are different, then we call that carbon, what we call them? Asymmetric carbon. Also we call
like
them,
a hydrogen, a bromine,
Yeah.
and something, or
yeah, and also we call this carbon as a chiral carbon. Chiral. Chiral center, chiral carbon, chiral center. So this carbon is a chiral carbon. Why? Because all the substituent around this carbon are not same. Is it clear? Now I'm asking this about this carbon, something like this. I'm giving like CH3. I'm giving CH2, CH3. I'm giving H, and I'm giving you chlorine. Can you tell me, is there any chiral carbon in this compound? Let us start with
just
this.
a second, just a second. Well, where everything around it is different. Well, I don't see a carb. I don't see any carbon that's bonded 4 times.
Okay, now look here in this case. Let's start with this carbon. Okay.
Mm-hmm.
Okay, I'm writing like this, but all these three
Oh, never
hydrogens
mind. Yeah, all of them
with this
are
carbon,
okay.
right?
Yeah.
So this carbon is chiral or not?
This one here,
This one is chiral. This is why this is not a chiral.
cause it's got 3 hydrogens.
Three hydrogen, same thing. Two
This
hydrogen,
one's got
two,
2.
same thing.
Can't be.
This one is three hydrogen, same thing. So only this one has different.
Yep.
Why it has different? It has one side, it has hydrogen. It has a hydrogen. Another side, it has Cl.
Mm-hmm.
Third side, it has methyl. Fourth side, it has ether. So this carbon is, I will write the H down. I will write this H here. So look, this carbon is chiral. Am I right?
Absolutely, you got it.
Carbon.
That's a brand new and yet another way of how now I how
Yeah,
I can
that's
look at
why
it.
I always suggest all the students, whenever you are taking, especially when you are starting the organic chemistry. Okay, because once you start in the beginning, first organic one you have to start much earlier than your class. Otherwise, the teacher is going very fast and you can't follow him.
I can't wait. I'm gonna be well. Actually, I can, but I just know I'm gonna be.
No,
well
you are
prepared.
going to be very good in even for summer. I think you are going to be ready. Don't worry about it. So you are going to be once you will learn the basic, even the part 2 organic is going to be easy. No problem. So look, this is chiral carbon. Now the thing is, I am writing here. I am writing like this. Which one is the okay? One before I will do that thing, I am going to there is a rule, and that rule is called Kahn and in gold priority rule. Now according to this rule, we give the priority according to the atomic number. According to the what?
Atomic
The
number.
priority is on the base of atomic number. Higher atomic number get more priority. Okay. Lower atomic number get less priority. So let's ask this one. Fluorine, chlorine, bromine, iodine. Which one is going to be higher priority?
Iodine.
Iodine, because this is a higher atomic number.
Yes.
Highest priority out of these. Am I right?
Yes. 50.
And also another important thing. Suppose this is a chiral carbon. This is a chiral carbon. Now we have hydrogen. Which one has the lowest priority in this case?
Fluorine. Wait, which? Okay.
In this case.
Okay, in this case here, which one has the lowest priority?
Mhm.
Would it be hydrogen? Because is 1.
Yes, per atomic number 1. So this one is the lowest priority.
What would
Okay,
it do
which
if
one
it's
is-
like a compound or something like that?
Which
Yeah.
one compound?
Like for. Well, never mind.
Okay. No, don't worry. I'm going
Like
there.
Like these.
Don't worry.
Okay, never
I'm
mind.
going to there. Okay,
Okay.
don't worry.
Got it.
Okay.
Got it.
The thing is, you will go like this. You will go step by step. For example, suppose this is here. Okay. I am going like here. Carbon. This carbon has 2 hydrogen. What it has? 2 hydrogen. Now it has carbon and 3 hydrogen. Okay. And another bond here is carbon with 3 hydrogen. Am I right?
Mm-hmm.
One is hydrogen there and one is chlorine. First you look that atom which is directly attached with your chiral center. From here, what atoms are directly attached with this atom?
Hydrogen, chlorine,
Chlorine,
carbon,
carbon,
and carbon.
another carbon. Okay. The one thing is definitely carbon has atomic number 6, carbon has atomic number 6, atomic number 1, and chlorine has atomic number 17. So I know already that highest priority is going to be this one
Chlorine.
because the highest atomic number. Okay. And now the next one is both of them are carbon, am I right? When both of them are same atom, then what you are going to do, look the next one. This carbon has 2 hydrogen, this also has 2 hydrogen. So you can say, so far the match is draw. CH2, CH2. Can you see?
Wait, you said this one has 2 hydrogen, but this one's got 3 hydrogen.
No, I'm right. Now I'm doing this one, okay? Here we have third hydrogen, but the third bond is carbon. These two is same, so draw. No one win. But now after looking the third hydrogen, the third bond with this carbon is carbon, am I right?
Oh, okay.
So now you will make a competition between this and this.
Oh.
Because these are same, CH2 is same.
Oh, I got
So now I'm
you.
making
Okay.
competition between this and this.
How to assess
Hydrogen
the
is
different
lowest.
levels. Okay.
Yeah, just go like, so first you have to look the first point of difference. First point of difference. Because CH2 is same, that's why I put same.
Got you.
Now this one and this one.
Yeah.
So this one is less priority, this one is higher priority. So definitely the whole group, this whole thing is going to be second priority, am I right?
Okay. I understand.
And this whole group is going to be third priority.
Oh.
And the lowest priority is this, am I right?
Yes, now I understand. Yep.
Okay. Now I'm writing here again. I am writing this one here. The lowest priority hydrogen I am putting on the dash. I am putting on the dash. And another one I am putting like a chlorine, I am putting on the wedge.
On the wedge, okay.
Of course this is not they have to give them. I am just assuming right now. Okay. And the other two I am writing like this one. CH3 and C2H5. Am I right?
Yes.
C2H5. Actually I have to make like this one.
ET?
This one, 2, ET like this one, and this is dash H and wedge I can also make like this. Okay, but right now I'm making like explaining like this one. My first priority is what? Chlorine. Second priority is what?
It's that
Ethyl.
ethyl.
Third priority is what? Of course the fourth priority, but you don't have to look the fourth priority because it is behind you.
Methane.
So you can say your steering wheel, I'm making like a steering wheel, okay?
Or methyl.
Not showing the hydrogen. I am writing the first position chlorine here, the 1. I am writing the second position ethyl here, 2. I am writing the third position your on the steering wheel, CH3 here, 3. Now you have to move the steering wheel from 1 to 3. If you move this going from 1 to 2 to 3, you are moving the steering wheel clockwise or counterclockwise?
Wait, if we're going from 1 to 2 to 3,
Yes, in the order.
we're going clockwise.
Clockwise. So your this thing is going to be clockwise. Okay? Clockwise. When it is clockwise, you are going to use the word R. What we are going to use the word?
And what's that?
R.
What's that for? Like in reference?
R
to?
is actually the Latin word, I think, rectus, which means right.
Oh, okay.
Rectus, which means what?
Excellent.
Right. I think rectus, I have to double check that one, the Latin word. But it means right.
So does that mean like the orientation of how this is moving?
Yeah, but sometimes even I become confused that why it is right, because sometimes it looks left. So I'm going to explain this what the problem is. If you make a watch,
Oh,
12
is it because this is closer to us? or
okay.
something?
No. If you take a watch, 12 is at the top, 3 is here, 9 is here. Am I right? When you are moving it clockwise, like this, am I right? When you cross that 12, you are moving to the right or left?
We're moving to the right.
to the right. That's why it is giving right. Clockwise is right. So I don't care about this. I just look the clockwise and counterclockwise. And if you are moving like in the opposite direction, like counterclockwise, you are going to cross the, when you cross the 12, you are going to the left. Am I right?
Right, right.
That's called S. So counterclockwise is what?
S. Oh, okay.
S. So you have to write this. Whenever they say write the configuration or stereochemistry also, you have to show them R and S. R and S. Okay. So let me, I will write this same thing. I am giving like here. How we will give the name. Okay, I am going to write this thing here. Let me, I have to give the name of this one. Which one? This compound. Let me, I will rewrite this thing. C, let me I will write in the line bond structure. 1, 2, 3, 4, dash H. What is the wedge I gave you here? Chlorine, right? Chlorine. And definitely if you take a look, even without making those things, you already know from this structure, bond line structure, what is here.
We have CH3.
So definitely it's not a chiral, am I right?
Right, definitely not.
This is a symmetric carbon, not an asymmetric carbon. What about this?
That is, looks like it is the chiral
Chiral, because here
chiral.
one H, one Cl, one methyl, one ethyl group.
Okay.
Two different.
Okay.
What about this?
That one is not chiral.
Not chiral. What about
CH2.
this?
That one's not. No.
Not chiral. So now let's give the name IUPAC name, but now including the RS if there is a chiral center. So I'm giving here. My main chain is this one, am I right?
This kind of looks like an arrow pointing down, and then it's like if it were to spin, it would be.
One, yeah. 1, 2, 3, 4. Okay.
Yep.
What is the IUPAC name of this one? So far, whatever you have learned.
Okay, I'm gonna try and write it here.
Very good. Chloro. No. What you are writing? 2 chloro?
Let's see. 2 chloro.
Hydrogen is not a branch.
Okay. Got it. Okay. Would it all be one?
Butane, 2-chlorobutane, 4 carbon. Is it clear?
All one like that though?
Yes, all together,
Okay.
without a gap. Okay, now let me, I will show you name, how they write the name. Look how they are writing the name. They put in the parenthesis. Can you see this thing? In the parenthesis here,
3s, comma.
because
2.
sometimes there are more than one chiral carbon. In our case, we have only one. So you put this one 2s, 3s, or whatever it is, then put the comma, not the dash. Put another one if there is another chiral, and then put dash and the regular name, as you already know. So the same thing we are going to do here. In this case, your name is good. Where is that one? Oh, this is where we doing this thing. It is here. Yes, 2-chlorobutane. Okay. So now that which carbon is chiral? Second carbon, am I right?
Yes.
So you will put the parenthesis before this formula and 2, and now you have to tell it is R or S. In our case, where you are moving this, clockwise or counterclockwise?
Clockwise.
Did clockwise. So R, 2R, because the second number carbon is chiral carbon, because there is only one chiral center, so just close it, put dash and the regular name. This is the whole name, including the stereochemistry.
Wow.
Okay.
I bet
That is the whole
I bet
thing.
if on the first day of class she put something like this up and was like, "Can anybody name this?" And
No, not in the not
I
in the
go-
first class, because in the beginning they always start with the general chem,
Yeah, yeah.
which is chemical bond, hybridization, and then Lewis structure.
Yeah.
Then after that
Cool.
resonance
They
structure.
move into it gradually, but
Yeah.
kind of
So
quick.
so don't worry. But once you will become familiar with this, organic chemistry is just like a fun.
Excellent.
Okay.
Excellent. It's like a challenge that you look forward to, just solving the right way, the proper
Yeah.
way.
And let's try one more. Okay.
Yeah.
Mm, hold on. I'm going to write here.
Sure.
And they can give you line bond or they can give you content. Doesn't matter. Okay. Okay. Give the name with the RS configuration, everything. First of all, tell me that is there any chiral carbon or not?
Let's see. So C.
Start from any side and look which do you have a chiral carbon or not?
Yes. This one.
Is there any other one chiral carbon?
Oh,
Actually, I don't have to write CH3. It's already understood CH3.
right. Right. As this one too. They're the same.
The
Right.
same. Okay.
Yep.
So these two are chiral carbon, am I
Yeah.
right?
Yep.
So what number I have to give them? 2,
Okay.
3, 1.
Just
Because
a sec.
one of them is 3, one of. Let me I would make it different. So it will be numbering will be different. Hold on. I'm going to put like here this one. One more. From which side you have to start numbering?
The left.
Left to right. Okay. So the third carbon is, am I right? Third carbon is chiral and the fifth carbon, am I right?
Mm-hmm.
Third and fifth. So now first of all, just tell me third carbon is R or S?
R.
R, okay. Making a steering wheel, okay, here. I'm not showing the hydrogen because assuming it is the lowest priority is at the back. What about the methyl group is priority first or next? Which one is the first priority? This group or this whole group around third carbon? Which one I have to give the priority?
This one.
This one, the number 1 I am giving this. Then what next? Which one? This one, you're right, 2. Which one is the third? Third. Forget about the fourth one is there, but fourth one is this one. Okay, fourth. Now I'm making a steering wheel. Putting 1, Then putting 2 is where? 3 is here. And 2 is here. Am I right?
Yes.
2 is here. 1, 1, 2, 3. So how you are going to move? Clockwise or counterclockwise?
Clockwise.
So the 3
R.
is R or S?
R.
3 is,
R.
you're right, R. Now go to the 5th carbon and tell me about that by yourself. Like when you are looking the 5th carbon, this whole line from here it is coming. Everything is one group now. This is one group. This is one. Like 4 groups are there. I am erasing that one because let I will erase the whatever the group I make that one at that time.
R. Is this one R as well?
I'm going to make another one. Okay. So now what is the number 1?
This one.
You're right. This one is number 1 group.
And then
Like
this
I'm
is
good.
number 2.
Number 2 is this one.
Number 2
Three
is this.
Yeah, because 3 carbon are here. Look here. This is CH3, 3 hydrogen. This is CH2 and then you have another carbon. So this is going to win. CH2, CH2 and now CH2 and H is there. So CH2 common, but there's another H is there and we have carbon here. Bigger radicals are always going to win with the smaller radical. A simple rule. Is it clear? How many carbons are this in this one?
Say again.
CH3.
Say again. This
In
one
this
right?
case you have, okay, look here, the CH3 I am writing here. CH3, I am write CH3 and the other group you have CH2, CH2 and CH3. Now I am writing like this. I am writing the CH3 like this. CH, H
Oh,
and
never.
H.
Or it's spinning.
This one I'm,
If it's spinning clockwise, then it would be. Then it's
No, it
this
doesn't
one
matter
first, and then
spinning.
this one.
no, you don't have to look
and then that
spinning.
one. Okay.
Look here in this case CH2 and then you have carbon, am I right? CH2 is okay, but is cancelled because they are equal. Now the competition is between this and this. Which one is going to win?
The carbon.
So definitely the bigger group radical, ethyl is going to be more priority than methyl, propyl is going to be more priority than ethyl, am I right? So
Yes.
this is your second priority. First is this, second is this, and third is this. So I'm writing here 3, 2, 1. And now make a steering wheel. Where you are going to move? Clockwise or counterclockwise?
Counterclockwise.
Counterclockwise. Counterclockwise means what? S. So this carbon is S, 5th carbon. So 5 is S, 3 is R. We already predicted 3 is R, am I right? So now give the name of the IUPAC name. But you already know 3 carbon, there are 2 chiral carbon. 3 is R, 5 is S, don't put the dash, just comma. Close it and then give the regular name. What is the regular name of this IUPAC name?
Okay. So it would be okay. I'm gonna write it.
First give the number, the longest chain. Yes, very good. What is out? Don't count the hydrogen as an exit or as a substituent. Anything else is substituents. 3, 5, very good. Very good.
And then we have 8, so it's octane.
Octane, very good. So look, it's the same thing. That's why I was gradually doing. First I teach you that main thing, then including the configuration, RNS, and now you know how to do all those things. Okay? Is it clear?
Yes, yes. I like how we are building and building and building up.
Yeah.
I like it.
Yes.
I like it. I like it, though.
But
Wow.
don't use the words exit, because teacher is going to, what is exit? It's a substituent. It is a group. That's I only use.
Got it. Got it. Got it.
Okay.
Perfect. Yeah, I'm gonna get some more cash sent over to you, and we're gonna email each other, and we'll get another session.
Yeah,
scheduled.
whenever you want, just let me know. Okay.
Thanks, Joffrey. Yep.
Okay, no problem.
Thanks.
I
Thanks.
want
a
you
lot.
like perfect in the organic, because once your foundation is going to be strong,
I
even
can't-
the part
oh,
2
yeah.
organic is going to be very easy.
Yeah, it's gonna be awesome. I'm excited. I'm liking it so far. I like it so far.
And also one important thing, because in the drug discovery, suppose you go to the chemistry, organic chemistry and drug discovery,
Mhm.
like you can design the drug.
Really? Yeah.
Yeah, in the chemistry. You have to take like some computer courses, because they have a computer like a designing of the thing and the organic chemistry together.
Okay.
You can go to that big pharmaceutical company,
Pfizer,
designing
things
the
like
research and making a molecule, new molecule. First they design on the computer, and then they prepare in the lab
that. Wow.
after studying their property.
Wow. Very interesting. I can't wait to learn more. Thanks so much for introducing me to this and getting me to be basically build my foundation and become a great student. Hopefully, I'm sure it's gonna happen. Thanks again. We'll talk
Right.
very soon. Thank you very
Okay.
much, Joffrey. You have a great evening. Take care.
One more thing,
Oh, yeah.
John,
Yeah.
because
Yeah, we
maybe
don't have to
when
rush.
when your college is going to start, I want to give like a 1 month introductory, 1 week once, like a 1 week only, like per one session per week,
Okay.
so that I can introduce myself, because majority of them don't know how is the online working. Okay.
Right.
So, but it is going to be like a class. Okay. Everyone has to come at the particular timing. Just tell me suggest me what time is good for all of them, so that all the students can come. Maybe at Saturday night or something like that, or Sunday night, Sunday something. So I can set those things. Sunday is going to be better. Everyone is going to be at home, or maybe Friday night, whatever is better.
Okay.
So that's going to be like a class.
Okay. Sounds good to me.
Okay.
Yeah, that sounds good. I'm gonna be I'll probably give you a call over the weekend and we'll set something up. Okay. We'll set up a
Okay, no-
session.
Okay.
All right,
Okay, take
Joffrey.
care.
Thank you very
Yeah.
much. Thank you very much. This was great. Thank
Okay.
you.
Bye.
Bye bye.
Take care.